welcome to SIM-PAC Live. I'm your host, Geoff Matthews, and today we're going to talk to Nathan Owens from Setpoint Refrigeration. Nathan is a leading refrigeration innovator when it comes to helping his commercial clients decarbonise and improve operational efficiency. But before I bring Nathan into the conversation, I do want to give some global context to the discussion. Firstly, many of you will be staggered to learn that a refrigeration accounts for 10 to 13% of all global emissions, depending on which data set you use. To put that into context, that is more than all road transport, sea freight and air transport combined. Just think about that. For many of you, your chillers are adding more to your emissions profile than your trucks. And we all rely on refrigeration in our daily lives. Our food systems rely on it. Our beer depends on it. And for those in hot climates, our modern living and working conditions are also dependent on it. So while refrigeration is an essential technology and its climate impact is profound, the big thing is these emissions are largely preventable. Furthermore, it's also cost efficient to make early and significant emission reductions. This really is low-hanging fruit. Nathan, when you spoke at SIM-PAC Live Queensland, I was impressed not only with the decarbonisation achievements that you help your clients gain, but how the operational efficiencies actually paid for themselves in an incredibly short period of time. Take us through how you are approaching this problem and achieving these outcomes on the ground.
Well, I've worked in the industry for probably about 15 years now, and going back probably 5 or 10 years ago, no one really had the mindset of having to sort of cut costs and try and look at how they could reduce their energy consumption. And it's only really come to fruition in the last few years that obviously power prices are going through the roof, and it was your refrigeration side of things is a massive contributor to a commercial site's power bill. So up until then, it was never really thought about. It was just part and parcel that you needed something cold, and it didn't really matter how much it cost to do so. But now that the prices are going through the roof and we're experiencing more and more fluctuations with the actual quality of power as well, it's becoming more and more important, and to a point where if customers aren't looking at improving their energy efficiency, they can't even turn lights on. They can't even open their doors for the business. And I've had plenty of customers shut down because of the price of power. So we've sort of transitioned as well as a business to try and look at the bigger picture. Obviously, it's the crucial part of our business is the refrigeration and the electrical. So for us, looking at from the customer's point of view, we needed to pivot and change direction to try and help that point of view of how can we reduce the running and operational costs of their day-to-day business without sacrificing not turning the cold rooms on. So I think that's sort of been our biggest sort of driving force, is sort of moving with the times and staying ahead of the market, a lot of other competitors, to be able to actually look at the whole site, the bigger picture, and try and actually reduce those energy consumptions on that the refrigeration side of things.
And tell me, reducing the energy from refrigeration, what are the areas that you look at I'm assuming that you're looking at energy modulation. I'm assuming you're looking at some capital investment in new variable speed drives. And tell us where you look for these efficiencies.
Yeah, well, if they're an existing customer or even new customers, we can go in and do an initial assessment to actually see what their existing sort of power usage and their typical power usage is like. And then obviously it'd be great to just spend lots and lots of money and make the most efficient system possible, but then it's counterproductive, because you might spend a lot of money on CapEx to replace something that might have been operating well, but you sort of offset the dollars spent to outlay on buying new gear, which might have been a lesser efficient system. So we usually try and look at what we can do to change and evolve an existing setup to make that more efficient. So like you said, you've got lots of different options from a retrofit point of view, whether it's VSDs, variable speed drives. They've been a big change probably in the last couple of years, where prior to the increased power prices, the return on investment of adding a VSD was sort of far outweighed how long it took to pay it back. So now we're sort of seeing return on investments of between 6 to 12 months on improving and adding those retrofittable VSDs.
Which falls into OPEX rather than CAPEX too. Taking out of a year's operation. Can you explain to me, because I'm not that technology savvy, why does a variable speed drive help reduce the energy cost?
Your normal refrigeration systems are sized from a heat load point of view for worst case scenarios. So a lot of the time, especially in Australia with our ambient conditions through winter and summer, varying let's say 30 degrees on a normal day, a lot of the time these refrigeration systems are way oversized for what they really need to be running at, which then results in a lot of short cycling, inefficient operation, start and stops all the time. So there's two aspects of a VSD which improves the overall energy efficiency of that system. The first is obviously being able to vary the speed of the compressor to then reflect the relevant capacity required. So it can slow it right down to a fraction of its normal operating speed, and which then obviously gives you the energy savings in terms of input power. The other side is reducing the peak demand. So your normal direct online compressor will start and stop quite frequently, and that starting is quite a high torque environment where it takes approximately 7 times its initial running input power just to start the motor. So the variable speed drive will actually speed the compressor up slowly rather than being straight on 100%. So that reduces and eliminates that high starting current and that peak demand significantly. So.
And talking about peak demand, are you doing much with energy modulation where you're using timing to overchill or chill down stuff and to try and avoid those peak times, and also maximize the use of low cost energy, especially in Queensland during the middle of the day?
Yeah, now that we've become aware, to be honest, didn't really think of it like that. But obviously you've got your bell curves with solar renewables during the day, and sort of different operating costs for power. You're definitely trying to tweak day-to-day operations of these cold rooms to sort of be more efficient with the times that compressors are running, defrost cycles, and then, like you said, over chilling or reducing temperatures prior to maybe a peak event or a busy time in the afternoon. If we can pre-chill a cold room at a certain time every day, in preempting something that's going to happen from the day-to-day operations of that factory, for example, then we can definitely get ahead of the temperature demand that might be put on that cold room.
I know that you were finalists in the SIM-PAC Live Sustainability Awards with the works you did with Beefy's Pies, where they also shifted their operational times from where they traditionally bake pies to move it so they could use more renewable energy during the day. Are you seeing clients starting to look at things like that?
Yeah, and again, that comes down to us sort of enlightening them to those sort of facts as well. It's, like I said, a lot of people just sort of took it for granted that it was cheaper to pay everybody an 8-hour shift and try and get everything done as quick as possible. Whereas now, especially with increased demand and higher productivity in terms of the actual facility, they might need to be operating longer, but then we can also help them learn and adjust to, potential savings in different time frames and operational costs as well.
Fantastic. And what about one of my favourite subjects, the use of industrial waste heat? And it, you know, because to make something cold, you've got to make it hot. You're producing heat, and that heat is usually just vented into the atmosphere, and it's one of the reasons that refrigeration's got this big carbon emission profile.
Yeah.
Have you done any work about trying to reuse that waste heat?
Yeah, well, that was part of that finalist award that we were involved in last year. So that's again thinking outside the box. We sort of touched on it briefly. I've sort of always had that in the back of my mind. I've never liked the fact that we work in that heat. We've got a cold space inside, but then we're trying to fix something outside, and it's scorching hot. And thinking we're just wasting all of this, this heat energy for no reason. It's just trying to get rid of it. So, when we started looking at beefies, that was the perfect test case, because they were actually wasting so much energy to try and make hot water, but then they were also wasting so much energy trying to make cold rooms cold and freezers cold. So it was just a matter of trying to think outside the box and go, okay, how can we transfer heat energy and air or refrigerant into the water? So yeah, it did take a little bit of trial and error and a bit of consultation with the relevant engineers and that sort of stuff to sort of come up and devise that principle, I suppose. And again, it's nothing brand new. It's it's been done on much larger scale and in different ways before. We're not trying to reinvent the wheel. We're just I guess changing the direction that it's turning. So yeah, it was a bit of fun trying to, it's definitely trial and error. Don't get me wrong. It was very calculated to start with, but it was definitely like, ooh, we think this will work, but ultimately it worked out far better than we expected. So hence why it sort of probably transitioned to what we're doing now. We're doing a couple more sites as well. So it's sort of, evolving, and we're improving each one as we go, adding on to it different stages, different techniques and different processes.
Yes, fantastic. I gave a presentation a couple of weeks ago to a group in Sri Lanka. I called it the circularization of industrial heat, and that is to use the heat itself, the energy in a circular economy, and to reuse it to heat water. As we know, energy can't be destroyed; it can only be transferred from one form to another.
Yeah, that's it, exactly. And I think that's the biggest thing. If we can, we work at a lot of butchers and like I said, beefies, food production facilities where they need that hot water, which is easy to transfer now that we've sort of worked out that concept and that principle. But on the bigger picture, how could we store that wasted heat energy in the form of heat and give it to someone or transfer it to somewhere that needed it?
Yes.
I've sort of got a couple of customers in a sort of very green sort of environment where they've got multiple different tenancies in one building, and they all have that aspect of trying to be green. But the butcher uses cold rooms, and he just wastes his hot water or his heat out into the roof. And then you've got a coffee producer who's roasting coffee with ridiculous amounts of wasted heat energy just going out the chimney stack. But then we've got clean up in the butcher's area, and we've got coffee machines continually boiling water. And I'm trying to work on those guys because again, that's the next sort of progression, is looking rather than just one individual customer. It's looking at that whole site mentality and how can one person's waste help the next person. So that's sort of where I see it moving towards, is sort of the bigger picture as well.
Yes, because water's a great medium for storage, and also preheating is also really, really efficient. Even if you have to use a final boiler to get your temperature, having preheated water coming in is a really efficient.
Yeah, exactly.
Yes, fantastic. And what other examples and customers are you working with or have worked out there that you're seeing this new thought process of we can be more efficient in operations and we can decarbonise by having better refrigeration and efficiency?
Yeah, well, our niche market, our specialty that we're sort of aligned with our customers is that sort of small to medium commercial. So, anywhere that sort of has multiple cold rooms, multiple, assets, so to speak, RSLs, bowls clubs, surf clubs, sort of that wholesale food industry. They're the sort of, it's the same term, that low-hanging fruit of the potential of savings in that industry, I think, is probably larger on the bigger picture than trying to shoot for the top 5% of our refrigeration sort of sector and then the industry and the customers in that area. So, if we can improve those small to medium sector size customers, there's a lot
Yes.
more of those in total volume than I think people realise.
Yes, and again, it's low hanging fruit from businesses that can get immediate gains. Just tell me, do you work with power and power factors and electronic pollution and electronic monitoring of power on sites?
We've only just really touched on it in terms of the power monitoring and involving the power factor side of things. Obviously, there's so many different higher end technologies that can monitor the harmonics and all of those sort of incoming factors which are going to contribute to that side of things. I think it's probably a little bit too far above what our sort of size customers really would embrace at this stage. Again, just from a reward point of view, cost versus reward for what might be done. But we've spoken to a couple of the guys, from SIM-PAC like Azo and things like that who, have the ability to do that. And it's only a matter of time until, those technologies are, just like the VSDs, not viable. And then as it sort of becomes more cost effective, they do. So I think it is only a matter of time until that's more relevant.
Yes.
And we're also seeing, I suppose, the quality of power just in general, from dropouts, voltage fluctuations, all of that sort of stuff is becoming more and more frequent. So again, it'll be more relevant.
So Nathan, tell me about the refrigerant gases. I think I've got a company that's going to speak in Perth, in SIM-PAC Live Western Australia, that has got natural refrigerant gases. But what are you seeing? What are you seeing to mitigate the damage that these really bad gases do, and where do you see that going?
Yeah, I think we're in a bit of a transition period at the moment. I think we're probably a couple of years behind the European countries and all of the regulations they have over there. They've sort of phased out most of our mainstream gases already over there. So it's only a matter of time until the everyday gases that we're using and refrigerants that we're using these days will be phased out, and we're seeing it each couple of months. We're having reductions in supply and hence increased prices. So, they are, and we are transitioning towards that, lower GWP, global warming potential refrigerants, which is great. But I think we need to also bear in mind we need to be able to support those refrigerants and those natural refrigerants and hydrocarbons in the field. There's so many more regulations and changes to the licensing and stuff like that are concerned with those changes. So I think it's a slow progress, but definitely moving towards that side.
Is better maintenance part of stopping those gases escaping?
Yeah, like you said, I think the portion of the refrigeration sector is not just the energy use; it's the refrigerant itself, which is obviously harmful for the emission side of things. So maintenance and better installation processes and all that sort of stuff will definitely be a major contributor to making sure that the potential release of refrigerant is limited for sure.
And do you also see maintenance on plant adding to efficiency? Do you go in and plant just hasn't been maintained well enough for the system to operate?
Oh, in so many ways, dirty equipment, dirty condensers make things run harder and run hotter. Dirty evaporators and dirty cold rooms, don't allow that proper heat transfer and correct temperatures to be read, for example. Open doorways, dirty seals, broken seals, they all contribute to a lesser efficient system. So people might think it's a little tiny portion of what they use, but in the grand scheme of things, it all adds up and makes a big difference in the end of the day.
Nathan, I want to bring you back to the operational efficiency and a total benefits, because I know we went off down a little rabbit hole there. Tell us about the other sides to operational efficiency that businesses can gain by looking at the total systems approach to their refrigeration.
Yeah, I think the unrealised gains of productivity, especially like at Beefy's, for example, by doing the heat recovery and transferring that wasted heat to boost the temperature of the water. Prior to us doing anything, they were relying on purely water pressure and a poorly efficient instantaneous hot water system that couldn't keep up with the volumes and flow rate to wash and blast off the fat off these tubs. It took the guys far longer than it should have, but it's just how it's always been, so they didn't take any notice. The guys were depressed, they were bored, they were sitting there with their hands in their pocket trying to sit there and just blast this meat and this fat off these tubs, and they weren't really getting anywhere. As soon as we actually boosted that incoming water temperature to about 55, 60 degrees, you should have seen their faces. They were excited. They couldn't believe how well it was working, and they actually felt like they were getting somewhere instead of just repeating the same thing over and over again. So, that staff morale, that increased their productivity and their whole process through the whole factory, dramatically. It was great to see, I suppose, from that point of view as well.
Yeah, no, interesting that we find that across businesses more and more. Oh, we've always done it that way. And, I think the one thing about high energy prices, the one thing it's going to do is make us question all our industrial processes. And we do have to reinvent them all. But everything that was designed to run on plentiful fossil fuels 24/7 needs to be reinvented. And that's just about everything.
Yeah, that's it. Exactly right.
And I would imagine a company like yours, with these higher energy costs, suddenly refrigeration is going to be more important. And companies like yours that are able to deliver operational gains and also see across these efficiencies, I imagine you're going to have plenty of work going forward.
Yeah, well, it's hard because up until sort of touching and expanding into this sort of sector of efficiencies and all that sort of stuff, it's we've got a big customer base as it is, and now that we're starting to actually be able to support more and do a bit more outside of the box, it's definitely taking away time. So it's going to be interesting to see if we can expand ourselves, or whether we can sort of lead into more consultancy based sort of things to help other companies like ours do the same sorts of things. So
I'm sure that with your learning curve that you've done is valuable in the marketplace, because we're all going to have to do it. Eventually, all of those surf clubs, all of those small businesses are going to go through this. And things like looking at that 55-degree hot water coming in before you're only needing to heat it to the final temps you need, just coming off the back of your chillers is it's such a no-brainer to do. And so good on you. It's one of the things that we see at SIM-PAC is these grassroots businesses doing innovative work and forging ahead, and it's great. I love it.
Yeah, no, it's been interesting. It's definitely been challenging in some ways, but also exciting to sort of try and think outside the box and evolve with what we need to do to sort of stay a bit ahead of the times, I suppose.
Wonderful. Look, thank you so much for coming on the show, Nathan. And
No
for our audience, if you stay tuned, you can ask Nathan questions in the chat, or in the comments, either one, depending what application you're using, down on YouTube below. And we'll be online for about next 20 or 30 minutes and answer any questions you may have.
Thank you very much for having me. Appreciate it.
Thank you.